What's up, gamers? Today we are going to talk about domain and range of functions. So what you're going to learn today is just how to figure out what a domain and range even are. So we're going to go over the definitions, and then we're going to figure out how to write them down by just looking at a graph. I'm going to give you a couple of examples with equations, but the real goal here today is be able to just look at a picture and be able to write down the domain and range. We're not so much worried if you can do it from a function. All right, so let's start with some vocabulary, right? The domain is the set, and set here just means a list of numbers. That's the mathy word for list of numbers. The set of all x values where the function is defined. So one thing we need to really pound into our heads is domain goes with the x values and the x-axis. If you're looking for how high up the graph is, that's not domain. Okay? And what we mean by defined is just there is a graph at that spot. Okay. You probably guessed already that range is all the possible y values or outputs of a function. Okay. This means when I look at the graph, where or how high is it? Is it even possible to have that y value? Things like that. All right. So as usual, math vocabulary is super abstract and vague and not very helpful unless you already know what you're talking about. So let's go look at some pretty pictures and functions and try and figure out what these two words actually mean. So we're going to start with one of your favorite functions of all time. We're going to start with the parabola. And we're going to start with the parent function parabola, just the simplest parabola on Earth, f of x equals x squared. And we're going to use this graph to find its domain and range. All right. So let's start by talking about this function, right? Let's go mess around with this function, look at it, see what kind of happens, and talk about why. So anytime I'm looking at a new function that I don't really understand or I'm trying to study something, I just plug in random values and kind of see what happens, right? You just throw stuff out there and YOLO, you know, just yeet that thing out into existence and see what happens. So let's pick some x values and some f of x values, or rather some inputs and check their outputs and just see what's going on. When I pick random, I don't actually pick random. I've got like a favorite set. It's -2, -1, 0, 1, 2. So we're going to plug these into, sorry, we don't want 11. We're going to plug these x values into this function and see what happens. So if I plug in, let's start with the positives and go negative, so we do the easy stuff first. So 2 squared, that's 4. 1 squared, that's 1 times 1 is 1. 0 times 0 is 0. Now we need to be careful with our negatives. -1 squared, that means -1 times -1. A negative times a negative is positive, so that's +1. Same thing with -2. This is -2 times -2, so we get +4. So we can see when we plug in numbers, we'll get some, integers. When I plug in negative numbers, I still get positive stuff. So think to yourself, is it possible to get a negative number from this function? No, Mr. Barton, of course not. Of course not. Because anytime you take two negative numbers, and we always have to use 2, because the exponent is 2, anytime you have even numbers of negative things, all the negatives cancel each other out and become positive. So no matter what number I plug into x, this is never going to be a negative number. It always will be positive or 0. Okay, so now that we've kind of looked at that, let's talk about the domain and range. The domain is what x's can I plug in? And you might even want to write that as a question. I find math a lot easier if I think of it as what question am I being asked? Like put it in like dummy kid terms, right? You want to make it as obvious what you're talking about as possible. What x values can I plug in? Right? Like what's even possible here? Well, I plugged in positive numbers, those are good. I plugged in 0, that's fine. Negative numbers don't cause me any issues. Could you square 100? Yeah. Could you square 10 trillion? Probably don't want to, but you could. You could do negative a billion, you know, you could do negative 127 trillion, so on. You know, you could pick any number you want and square it. You just multiply the number to itself again. So that means I can plug in anything I want. Okay? So that means our domain is all real numbers. And this is just like the math symbol for real numbers. I'm never going to write this out again because I'm lazy. All right. So let's figure out, how do I get this from the graph, right? How do I figure this out from the graph? So if we look over here on the graph, first thing we have to realize is there are arrows here. Okay, I'm going to talk about this arrow business in depth on the next slide just so we don't get confused. But what we're asking is, what x values can I plug in? Or if I look at this graph, what x values does the graph cover or line up with? So it lines up with 0, -1, oh, sorry, that's -1, -2. And because there's an arrow here, this just keeps going forever. So it's going to cover everything over there. Same thing on this side, because we have an arrow, it's going to cover all of that space. So all of the numbers are going to get covered. Every single x value lines up with a piece of graph. Okay, so that's the domain. I'm going to erase a lot of this now so that we can see better. Or actually, I'm just going to erase the stuff on the graph. There we go. And we'll change colors. All right, so range is just the opposite. We want to know what y values can I get. Okay, and this is why I picked the x squared function, because we can't get every single number. All right, if we go back to this chart, we can see we can get to 0. We can get 1 and 4, and if we really wanted to plug in some decimals, we could get weird ones, right? Like that's probably 1. I don't want to speculate. 0.2. I don't know. There's 0.5. There's 1. There's like 1.5. You can get the decimals. You just have to plug in weird x's. But we said we cannot get negative numbers. You see, our graph never goes below the x-axis. So we can't get to all these negative y values down here. So our range starts at 0 and only goes up to the positive numbers. And because there's an arrow here, it goes up forever. So it's going to positive infinity. So our range is from 0 to positive infinity. Now we need to put some brackets and parentheses on here. Remember from, I don't know, kindergarten, brackets mean include the end, and parentheses mean don't include. Okay. So did we include 0? Well, yeah, it's right here, right? So we want to include that, so we'll throw a bracket on it. And now infinity never gets a bracket. It's always a parenthesis. And the way mathematicians explain that is infinity is not a number. It's like a idea, right? When your brother says, you owe me infinity plus 1 something, you just call him an idiot and say there's no such thing as infinity plus 1, right? Infinity is not a number. You can't get there, so you can't include something that's not a number. Okay, so our graph goes from 0 up to positive infinity. Includes 0, doesn't include infinity because you can't get there. Okay, so there is domain and range for our favorite parabola. All right, let's talk about just some caution with these arrows on the end, right? And you're going to say to me, Mr. Barton, you're the greatest artist I've ever seen. To which I'm going to reply, I know. But let's talk about this. Sometimes when I ask students, how high does this graph go? The smart kids say it goes forever because there's an arrow. But I drew that. So sometimes I get lazy and I don't draw them and I just leave it like that. And then I ask, how far up does this go? And some student, without thinking, of course, clearly they know the correct answer of infinity. But naively, half-heartedly, they'll say, oh, look, it stops at 4. Okay, let's talk about my picture here. If you have a picture of your dog, your girlfriend, and your boyfriend, okay, and someone walks into your house and they see this beautiful picture, they don't exclaim, oh my God, your dog is only a head, your girlfriend and boyfriend don't have any legs. They understand that this picture is just a snapshot. It's a square that we can see. But obviously, people have legs. Just because you can't see them in a picture, we don't automatically assume these people had some horrible car accident where they lost both their legs and your dog lost his entire body besides his head and collar, right? So when you see this graph, you can kind of tell that it's been cropped or cut out of something because the lines just sort of end and it's a nice perfect square looking thing. So in my class, you get to assume that those have arrows on them because they do, right? Like, I can't draw an infinity graph, and unfortunately, I'm stuck to just cutting screenshots out of stuff, and it doesn't put arrows on there. So just like when you look at a picture, you know people have legs, right? Like, here's this guy's legs. Right? He looks like a chair, huh? You guys don't all have 4 legs? And this graph has arrows. Even if they're not drawn there, we know it has arrows. All right, good talk. Okay, so let's do one more example of domain and range. This time we're not going to look at any equations. We're just going to look at the graph and figure out what our domain and range are for these. This is a square root graph. This is actually, we don't care. We don't care. Like I said, we're just going to look at the picture. So for domain, remember domain is the x-axis. So we want to know where on the x-axis does our graph line up with. So it starts right here at 1, and this is a filled in dot, or it was at least until I wrote over it. See, filled in. So this is a filled in dot, which means we are including this point, and then this graph just sort of goes this way. Oh no, but Barton, please, there's no arrow there. It must stop at 6.3. No. Listen. Your boyfriend has legs, dog. There's an arrow there. So this starts at 1 and keeps going right for infinity, for forever. It goes forever. There's an arrow, dog. So starts at 1, goes to positive infinity. We don't include infinity. We are including 1 because it has a filled in dot. There you go. Now for the range, we are only looking at the y-axis. We want to know how far down does it go and how far up does it go. So our graph starts right here at 0 on the y-axis. The ordered pair here is 1, 0. So the y is 0. So it's going to start at 0. And then this thing goes up, up, up. Oh, an arrow, that means it goes forever to infinity. So parenthesis on the infinity, because infinities always get parentheses. And we are including this endpoint, so bracket on the 0. Okay, let's go look at a weird one. So here's some weird looking graph. This is meant to be a closed dot. This is meant to be an open dot. Hopefully you can see it's not filled in all the way. So let's look at our domain. This graph has an arrow over there. So we want to ask how far left, and that's an ugly and symbol. How far right does it go? Okay. So let's start with left because we always want to order our domain and range from most negative to most positive. So this thing goes left forever. There's an arrow there saying it goes up and left forever. So left forever, forever's infinity, but left is negative. So this is going to go to negative infinity. So that's where it starts at. It goes left forever. And then it keeps coming over until it gets right here and stops. This is at -1. So we go from negative infinity to -1. We're including this point, so we get a bracket. You can't include infinities because you can't get there, so we put a parenthesis. That's not all of our graph, though. There's still some over here, so we need to tell whoever the rest of our domain. So the way we add a little bit more on is we put our union to show we're attaching another piece, and then we put just the domain of this chunk here. So this one starts at 1, but because it's not filled in, we don't include it. So we put a parenthesis for 1. And then this thing keeps going forever because there's an invisible arrow there. So forever is infinity. And there's our domain. All right. Now let's talk about our range because this could get a little bit more confusing. So let me just erase some of this. There we go. All right. So now remember, range is talking about our y-axis. So we want to know how far down does it go and how far up does it go for range. So let's start at the bottom. The lowest our graph ever gets is right here. Keep in mind that we are not including this point though because it's an open circle. So it goes to 0 but doesn't include 0 itself. So we're going to go ahead and put a parenthesis 0. And then we want to know how far up does it go? Well, it keeps going up to infinity. So we'll put our infinity parenthesis. And now we're going to come over here and look at this. This has kind of already been taken care of because this goes from 2 up to positive infinity. So 2 and infinity are already included in this interval here. We don't need to rewrite this and say union 2 to infinity because 2 to infinity is in that thing already. You've already told me 2 to infinity with this. So you don't need to do 2 different chunks for your range because the other chunk is already included in the first chunk. So you would just put 0 to infinity. All right. That's the end of your notes. Go ahead and hop back in WebEx. If you have any questions, make sure you ask. This is one of the most confusing topics all year that students continue to struggle with till the day they die, unless you go to school for math, in which case you're like, oh, this is super easy. But if you have questions, please ask, because there's nothing more irritating as a teacher than telling a kid something, I don't know, in August, and then having them come to you in December and go, you know, I really didn't get that thing in the first unit. So ask. Let's hammer this out now. Let's do all the hard work now so that we don't have to do all this hard work later. You're not going to be able to avoid it. So let's just work hard now.